By the frog. And the duck.
Which duck?
Lesson 14, correct?
On the other side.
Right.
Yeah.
Yes.
Right there. Bones. All of them. Bring them to me, please.
We will be using soccer shoes and hot dog nutrition thingies.
Mm-hmm.
Okay. Are you all on the quiz?
Bring them to me.
And I'm still
Mine's
getting
open.
up.
Thank you.
Where's the one?
Let's see, how long is this one?
It's 18 questions.
Not terrible.
Yeah.
The first few look pretty simple, just kind of a, how do you do this? Like, what is the general procedures for these? And then we get into the actual, like,
Yeah.
trying some sample problems.
Marcus, can you turn that off, please?
Turn off for me.
You can still swing. Just don't do it with the sound.
It's like it. What the sound you gotta go upstairs or in the kitchen.
I was making sure my Excel sheets are already open. There we go.
Okay, I'm ready.
Me too.
You can go ahead and start. Like, you just get this thing's just taking forever to come up.
Okay. So in the ANOVA hypothesis test, we reject HO when there is sufficient evidence to indicate at least one mean is different from the others. That is true. As long as one is different.
Mm-hmm. Yeah,
That
true.
is- Then what requirements need to be checked when performing an ANOVA hypothesis test? Mark all that apply.
Each group can only distribute variances.
I know that
all but the first
data in each group are normally distributed.
Yeah, I think it's the second and third one.
Yeah, sample means all positive.
No, not that one.
No?
Yeah, not that one.
Oh,
The second and third one.
okay, thank
So all
you.
but the first.
Yeah.
Okay, sample means all positive. Oh, okay. That's equal.
Checking this normally distributed is the following. Substitution plot.
QQ?
Correct.
Okay.
So are you all still together?
Yep.
Yeah. I don't know why my Excel sheets aren't coming up.
We assume the variance in each group is the same if the following happens. The largest variance is less than 4 times the smallest variance. So number 2.
3? No, third one?
Two. The second one.
Yeah, the largest variance.
Yeah. But interesting that the instructor used 2 times, right? Instructor like a video instructor, the young guy.
Yeah.
Yeah. He said 2 times. Didn't he say? And but this text said 4 times. So which one
Yeah.
is correct?
Go with,
Probably the textbook is what I would
Okay.
go with.
I'd always
Thank
go with the textbook.
So second one, right?
Yeah.
Okay. Question 7.
An ANOVA hypothesis test is equivalent to conducting an independent 2-sample t-test between every pair of samples. If there are 3 samples, there are 3 pairs. How many pairs are there when there are 4 samples? 1, 2, 1, 3, 1, 4.
4? No, what does it mean? If there are
Two, three,
three samples,
I want to say
there-
6.
one.
How do you?
I don't know if it's really a mathematical way, at least not one that I saw. I just counted them out
Okay.
because you'd pair 1 with 1 with 2, 1 with 3, 1 with 4.
Mhm.
Pair 2 still with 3 and 4, and then you need to pair 3 with 4.
So
Six?
6
Yeah.
samples.
Yeah, that makes sense to me.
Okay, load up soccer shoes.
3 pairs.
This gets tricky because you need to watch where the A stops.
Is this still on the inference, or are we doing the categorical data?
I think we use both because we have to. If we need to make the QQ plot, you do the QQ plot on the
On the categorical.
categorical one, and then the inference one on the other one.
I don't know what's wrong with my freaking Excel, but it's like taking forever to open anything.
Don't you love technology?
Yay.
Mm, I'm sorry. Question 7. Could you explain it again why it answer is 6? I'm sorry.
So you need to look at how there's supposed to be a pair with each one,
Mm-hmm.
and so you need to pair 1 with all the others. So it'd be 1 and 2, 1 and 3, 1 and 4. And so now you don't have to worry about 1 anymore. And then so you look at 2. You need to pair 2 with 3, and then pair 2 with 4. And then the one left is pairing 3 and 4 together. Because you already paired them with all the others.
One pair. There's 3 pairs. 3 pair. Two sample tests. There's 3 samples. There are 3 pairs. How many pairs? 4 samples. 1 samples. There are 3 samples. There are 3 pairs. 1 to 2. 1 to 3. 2 to 3. Still. You said okay. 3 samples, right? 1 to 2, 1 to 3, 2 to 3.
There's 4 samples in this one.
Yeah. How many pairs? So 6 pairs. 3 pairs. Okay. Let me think about that. 1, 2, 2. 1, 2, 3, 2, 2, 3.
I have all my data copied over.
I'm almost done.
Just about.
Do we need to do the socks one as well?
Yes.
So I'm showing the smallest variance to be 27.208, and then largest being
Yes.
15.158.
You said 53.158?
Yeah.
Yeah, that's what I got.
Mm-hmm.
And so, yeah, that's definitely way smaller than times 4, the smallest.
So true.
Yeah, so that test good.
So it was 27.208 was the smallest variance, correct?
Yeah, that's what I got.
Mm-hmm.
Okay.
And the largest is the 53.158.
Mm-hmm.
And we're true. Hey, Barrett. Construct a QQ plot for each of the 6 samples.
So that'll be fun.
Well,
So
it's
now-
actually not that hard. What you do is you just highlight all of the variables, like 1 through 6, all the way down. And then you go to Excel and you go to Insert. And then you just make a scatter plot. And it makes it for you.
Scatter plot or QQ plot?
Well, the scatter plot is what Excel calls it. But
Oh,
it's essentially the same. It's the same thing as a QQ plot.
Oh.
At least I'm pretty sure that's how you do it.
So you highlight all the variables?
Yeah. And then you go to Insert, and then you pick the scatter one. At least that's how someone explained it to me. I don't know if it's exactly like...
because how
What?
there is a specific like QQ plot tab on the Excel sheet.
There
On
is.
the descriptive statistic one. So the one we use at the beginning of the semester.
Yeah. But does that one have a place where you can put 6 variables?
No, you wouldn't be able to put like all 6. You probably just have to put one at a time. I'm trying to remember how we sorted though. Oh, there we go. Just right click, sort smallest to largest. And yeah.
Parents.
So I think it is approximately normal.
Yeah, I've tested the first 2 so far and they seem good.
Hammer tips. Can you bring me my water bottle that's on the counter?
How are you saying you did the sort thing?
Right click and then
On the plot?
no, right click on it, like highlight all of your numbers.
Oh, you did it on the actual thing. Gotcha.
On the numbers, right. So yeah, right click and then about 2/3 of the way down, it'll say sort and then just hit smallest to largest.
Gotcha. Okay, how do I make this stupid thing go away?
I mean, considering we're doing the problem, I'm guessing it's all going to be good. You know? They just want to make sure we know how to do it.
Mm-hmm. So question 11 is true?
I think it's true,
Not
yeah.
sure.
Mm-hmm.
Sounds like a rowdy bunch over there today.
Yeah, they're having issues.
Yeah, the socks one is the only one that really seems like it kind of splits off a little bit. but it's still mostly along the line, just down towards the bottom. It just kind of has a weird little spike.
Yeah.
Keep asking me this stupid question.
Okay. So now I need to remove the SOX data
Yeah.
Oh my gosh, there.
and see how it changes. Oh, that went up by a lot.
Yeah, it did. I got 0.309.
That's what I got.
Me too.
Okay. So the test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or the left?
Right. No.
I think it's left. Wouldn't it be left?
Wait, so the test statistic formula.
So the test statistic is 1.216. So the p-value is lower, so wouldn't it be to the left of it?
If it's the
Is the p-value the area to the right or the left? Because we're looking. Wait.
like the lesson.
Yeah, I'm just taking a look in the textbook again.
Oh, actually, so it says the p-value is the p-value for an ANOVA test is the area in the right tail.
Right.
So yeah, it is right.
Right, skewed. The values of F are always negative. The ANOVA test is the right tail, so we'll never
Yeah.
divide the area.
Wait, what'd you guys get for question number 12? Mine won't give me an answer every time I do it.
It's 0.309.
I guess let him play. It is his toy. It's not okay.
All right, so ready to load up the next data set?
Yeah.
So it's left or 13?
Right. It's correct. No, I mean,
Right.
it's right.
Okay, great. Now I gotta-
Left is wrong, right is right. Okay. Researchers at the Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat, mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they record the type, the calories, and the sodium level. Their data is included in the data file. Use the data file to answer the remaining questions. Let's examine the calories first. Construct QQ plots of the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met. You're going to do both QQ and variances all in one, right?
Yes.
Would anyone even like divide it up? Like I can go and work on the QQ plots if someone else wants to put in the information for variance.
I can do that.
Okay. So how about guys do QQ, girls do variance?
Okay.
I can't.
You fit see the lion?
Oh my gosh, stop asking that attention question. Marcus.
I just call them meat and not pork.
Wanna go for a drive? Parents. Dude.
Okay, as far as I can tell on the QQ plots, it all looks normal.
Yeah.
I have the variances. What's it saying?
Oh, this stupid thing didn't. Gosh dang
The
it.
variances are
Mine
not
was
equal.
the last two things.
So the variance is too, like one of them is too big, too small.
I mean, they're all like one is 508, one is 512, and the other is 636. So they're all over the place.
Well, remember how that's where the variance is. You look at the smallest one, multiply by 4, and as long as the largest one is less than that. So really, they could be in a decent range. Like, for instance, if we had a variance of 25, we could have anything up to 99 as a variance.
Yeah, but it's not equal. Because it's 508, and if you times 508 times 4, that's 2,000, and the largest variance is 600.
No, so that means it would be good. As long as the largest is less than 6,000.
Okay, my charts keep coming up.
6,000.
So wait, I'm confused.
So the variance test, in order to see if we're able to compare these data sets, take the variance of the smallest one and multiply by 4. That has to be, they all have to be less than that. So the largest one has to be less than that value.
Okay,
Mhm.
so it is.
Okay.
So are they all normally distributed?
Yeah, they were.
Mm-hmm.
Marcus, please don't make a mess. That's not okay.
So it's the first one then.
Right. The assumptions have been met.
Yeah. It's the same for all 3 times.
So all of that is like I have all the ones in the ANOVA for this one and all of the
Set it on Barrett straight.
data that
Is
he's
that
given.
showing on question 15?
Huh?
Like all the values on question 15 it is showing is correct?
Yes.
Fantastic.
Yeah.
Well,
I-
in that case, because the p-value is definitely below, so we can...
And
I'm
the,
sorry.
the means are all different.
You got. We are doing a question 15 or 16.
We're doing 15.
Okay. Okay, true.
Calories.
So I think it would be the third one.
We have sufficient to claim all right type.
Also, this is a different mean
Different.
number. Yeah.
Because one mean is 156, another is 158, and another is 118.
118.
But remember, like technically, as long as they're close, like the 156 and 158, those are probably like close enough that we not.
But
And so, in general, with these types of tests, we prove that at least one is different. So I'm thinking it's the bottom one.
I think so because the p-value is 0, and it's smaller than 0.05.
Well, because yeah, variable 1 and 2 are really close. Variable 3 is the one that's off. So yeah, I think number 4.
So
Like, did you guys watch the video that she had posted and like the announcement, how they did that one example about the poster boards and what color the Beatles were attracted to? Like the blue and the white one,
Yeah, I haven't had
and
time.
eyeballing it with the box plot was close. So
so small, that means reject to H0.
So the last one.
right.
I think so.
Mm-hmm.
Okay, so I did on question 16, the variances are equal. I did that math already. So we just need to do the QQ plots.
Gotcha. Let's see.
I'm pretty sure it's going to be distributed equally for all of them, but better safe than sorry.
Right.
And I'll go ahead and just put the sodium in the ANOVA one.
Okay, beef is even. That one's even. Okay, I'm showing them all evenly distributed.
So the first one, maybe.
And that's what it looks like. The assumptions have been met.
Okay, I went ahead and put them all in the QQ plot for 17, and the p-value is 0.180.
Okay,
Actually,
no,
just kidding. It's 0.179. It's 0.179. Sorry.
And then you guys said question 16 is second one?
The first one. The first one. And sorry, 17 is 0.179.
Right. Really fast. Actually, backing up to 16, because like how it mentions the possible problem with the QQ plot for poultry. Looking at that one again, like how it's technically is along the lines, but it's like is slightly different. I don't know.
So do you think?
I feel it's like really a matter of judgment almost. It's like, how do you know what is and isn't on the line, because it's in a linear pattern. Like here, let me see if I can flip this around for you guys.
A screen share or something.
Whoops, I hit something. Go back. There we go. So that's what that looks like.
Okay, mine doesn't look anything like that.
What does yours look like?
My webcam's the only thing, so I can't turn it around. But I don't know if I'm doing my QQ plots right because they're not turning out the same.
They're not linear?
Did you take out those last three on the first variable so that they were all the same? Because every time I try to do it, it takes the last two variables and just combines them into one.
Really?
Yeah. Then if I try to adjust it, it gives me variables for each vertical line instead of each column. Like, so I don't think I'm doing them right.
Yeah, because we're just looking at like the one for because we're just looking at sodium right now.
Mm-hmm.
Just the one column, and it'd be for like right now I'm looking at poultry. Yeah, I just copy and pasted the data.
Because yeah, like it's only giving me 2 series instead of 3. Like, because looking at all of them, because we should have meat, beef, and poultry. And it just keeps on giving me 2 series instead of 3 series.
Are you putting them all in at the same time, like for beef, pork, and poultry?
Yeah.
Okay, yeah, I was just doing the one at a time. So this is
that's probably what we're doing.
Yeah, so I don't know, like because it's still kind of along the lines of, but the next
I
question.
think that would be not.
You think it would be different?
I do. So I think it would be the third one.
Okay. Because yeah, especially just the way that they word the next question just makes me doubt that. So that makes sense. Let's go to number 3. So and then with the level of significance 0.05, that means that we do not have sufficient evidence to claim that they have different sodium levels.
So wait, would we do the second or the fourth one? Oh no, just kidding.
Now we
The second one. It would be the second one. Sorry.
Question
Yeah,
18.
the second one.
Yeah, question 18 is the second one.
Well, wait. No, it will be fourth because it is like we're all looking for at least one hot dog.
Okay, that's why I was wondering.
Yeah. So in general, with these types of tests, they are looking for
just one.
Just one. Could be multiple, but at least one of them is different.
But like I'm looking at the means right now, and they aren't anywhere close to each other.
Mm-hmm. So that's just where it's like that weird, like, well, are we like with going with how the textbook is like, oh, we're focusing on the one, do we go with that? Like that's what they're trying to teach us, or do we go with right now, they all are different?
I don't know.
I'll go ahead and put in number 4 and submit and see what we get, okay?
Okay.
Let me just make sure I do have answers in all of them. All right, submitting. See. Okay, yeah, I'm showing we missed one, and yeah, it actually is that last one.
It is.
Try and submit it. Yeah, so go ahead and try and submit it with
the second one.
All 3.
Second one.
The second or the third one? What is the second one?
Second one.
I'll submit with the second one and see what we get.
Okay, you guys are-
Yeah, it's the second one. I got 100.
The second one.
Okay.
Awesome.
Okay, so